So today we're talking about describing distributions of numerical variables. We've talked about three types of graphs for graphing numerical variables: dot plots, box plots, and histograms. When describing distributions, sorry you guys, I'm starting with a few of the notes filled in, but when describing distributions, we're talking about four key characteristics, which I'm going to abbreviate with SOCs: shape, outliers, center, and spread. First, we're going to start with shape. The first shape we're going to talk about is symmetric. A symmetric graph is when the left side of the graph is a mirror image of the right side of the graph. Meaning if I fold the left side on top of the right side, it almost matches. Remember, it will never match perfectly. It's approximately symmetric. The next graph is skewed right. A skewed right graph is when the right side of the graph is more spread out than the left side. The right side of the graph is more spread out than the left side. So right side is more spread out than the left side. So my students in the past tell me this is kind of like the opposite of what they may think. Let me sketch you out a graph. The right side So remember, draw a curve over it. If you draw a curve, sometimes you think of it as right tail. The tail is longer on the right side. Okay, the right side of the graph over here is the data is way more spread out than the left side of the graph. Skewed left is the opposite. The left side of the graph is more spread out than the right side. So the left side is more spread out than the right side. You know what? I think I'm going to start writing in pen. It might come out a little bit clearer for the video. So in a skewed left graph, the left side, and maybe there's an outlier, so maybe there's a gap. Again, draw curves over your shapes to really help you. The left side of the graph is more spread out than the right side. Okay, bimodal is when the graph has two distinct peaks. So the graph displays two distinct peaks. Distinct, so they can't be next to each other. They're separate. So two distinct, they're separate from each other, because a lot of times if they're next to each other in the middle, it's symmetric, and a lot of times if they're next to each other on one side or the other, it's either skewed left or skewed right. Okay, the last one is uniform. The last one for shape is uniform. It's when the height of all the bars are approximately the same. So the heights of all the bars are about the same. So you remember, they're about the same. They're not going to be perfect. They're about the same. So if I were to draw a line around this one, it's almost like a straight line across, almost like a horizontal line. A lot of times I use the words here, approximately uniform, never going to be perfect. Okay, go ahead, try your turn. Try and label A, B, C, D, and E. Okay, the first one, you guys, hopefully you put approximately symmetric. Again, draw a curve over these to help you out. For the next one, draw a curve. It's skewed left. Letter C, they're all about the same height. So approximately uniform. You guys, if you don't have approximately for A or C, that's fine. You're just going to see me use that, okay? It's fine if you don't have it, totally fine. D, two distinct peaks. So that's bimodal. And E, if I draw a curve, that is skewed right. Okay, questions? Okay, now shapes of box plots. For shapes of box plots, you guys, our three choices are going to be either approximately symmetric, skewed left, or skewed right. Okay? When you're comparing the shapes of box plots, you guys, you're looking at the left side of the box plot versus the right side of the box plot. So when I say left side of the box plot, left side is like your min to your your min to your median. And the right side of the graph is like your median to your max. So for this first one, the left side of the graph, my min to my median, is about the same distance from my median to my max. So this one is approximately symmetric. Try the next three. Okay, so there's G, H, and I, skewed right. Okay, right side is more stretched out than the left. H is skewed left. The left side is more stretched out than the right. I is approximately symmetric. So that was shape, okay? Next one, outliers. What is an outlier? Some of you may have heard this before. Keep in mind, you guys, we looked at the outlier formulas yesterday, correct? There's two of them. One to check outliers in the lower direction, the other to check outliers in the upper direction. A data set does not have to have outliers. A data set could have one outlier. A data set can have more than one outlier, okay? So an outlier is a value that does not fall in the pattern with the rest of the data. A value that does not fall in the pattern with the rest of the data. Bless you. So why do we identify outliers? A couple of reasons. One, you guys, we identify outliers because it could indicate that a data point needs correcting. When I type in your chapter 3 test scores, if I put it in my calculator and see if there's any outliers. You guys, if I see there's an outlier of 4, I can be like, I don't remember anyone getting a 4. I was grading chapter 3 test. Maybe because I entered it in wrong. It was supposed to be a 24, okay? So it could mean that a data point needs correcting. Another reason, a special phenomenon that deserves to be recognized. One of my favorite basketball players, Kobe Bryant, had, I can't remember if it's 81 or 82 points in one game. His average was 30. Clearly that was an outlier. It was deserved to be recognized. An awesome performance. The third reason about identifying outliers, you guys, because they can have a drastic effect on the mean and the range. Okay, so that's outliers. And then we have the formula that we used yesterday. Okay, center is the next characteristic we're going to talk about when describing distributions. That's a C. Okay, 2 common measures of center are the mean and the median. You guys probably know this, but another word for mean is average. And another word for median is the middle number. So I showed you guys yesterday how to find the median, right? It's in the 5-number summary. Scroll down on one variable statistics. Now, for the mean, you guys, don't worry about grabbing your calculator right now. I think I have data in here. Yep. When I go one variable statistics, just like we did yesterday, you guys, X bar, the very first number that comes up is the mean. So maybe write that down. It's the mean in your one variable statistics in your calculator. You do not need to calculate these statistics by hand, okay? And the last characteristic that we're gonna describe is spread. But before I go to spread, you guys, now that we know about the mean and the median, let's talk about these real quick. How do the mean and median relate in a symmetric distribution? Well, if the left side of the graph is a mirror image of the right side of the graph, then the mean and the median are about the same in a symmetric distribution. So I use the little about symbol. Sometimes they're exactly equal, but they're close to the same. Now, which other one of these shapes, we can't have a generalization for bimodal because we have no idea where those 2 distinct peaks are going to fall, if one's in the middle and one's on the left side, or if one's on the left side and one's on the right side. So notice that there's nothing here for comparing the mean and the median. But which other one? Skewed right, skewed left. Sorry, I didn't highlight these earlier. Or uniform. Do you think we'll have a mean and a median that are about the same? Uniform. Now let's talk about the relationship between the mean and the median in the skewed right distribution. You guys, in a skewed right distribution, you have a few values at the upper end, maybe even potential outliers, okay? What are those values at the upper end going to do to the average, going to do to the mean? They're going to bring it up or down? Up. So in a skewed right distribution, the mean is greater than the median. Now, in a skewed left distribution, those couple of values are at your lower end of the data set. Potentially an outlier. They're at the lower end. What are those few low values going to do to your average, your mean? It's going to bring it down. So in a skewed left distribution, the mean is less than the median. Okay? Here we go. Spread. The formula for range, maximum minus minimum value. We learned IQR yesterday, which is interquartile range. It's Q3 minus Q1. Okay, so we're going to do this last one together, you guys. It says describe the distribution. Anytime in your homework tonight, when you see describe the distribution, you need to talk about all 4 key characteristics: shape, outliers, center, and spread. So I'm not going to go through the outlier formulas again right now, you guys. So we're just going to kind of eyeball for outliers today. But on your homework, it will ask you to show work for the formulas from yesterday. Okay? So here we go. Here's our graph. There's kind of 2 shapes I would potentially take for this. Look at the shape. Kind of draw a curve. That's what I taught you to do. What do you think is the shape of this graph? Okay, so for this graph, whichever one it looks more to for you, skewed left or approximately symmetric will work. So the distribution, and this is the distribution of runs scored for the American League. The distribution of runs scored for the American League, you can abbreviate it with AL, is right either skewed left or approximately symmetric, whichever one you think it more is. I'm going to write a skewed left. So I talked about shape. Now I'm going to talk about, outliers. Okay, we didn't do the formulas here, and sometimes you won't have all the data. So in this one, you guys, I'm looking to see if there's any gaps. Hopefully you see that there's a gap right here in the data. So there's a potential outlier at this value, which is 901. So I'm going to add here and a potential outlier at 901. Now, we've talked about outliers. C stands for center, okay? Go ahead, you guys. Why don't you go ahead, take a minute, put the data in your calculator and bring up one variable statistics from yesterday. Put the data in your calculator and bring up one. So if you put the data in your list and then you go to stat, arrow over to calc, number 1, enter on through. There's your stats. Remember, X bar is your mean. Scroll all the way down and you'll get your 5-number summary. Okay, so C stands for center. You can use either measure for center. You can use the mean or the median. So I'm going to write the center is I'll use the median. Is the median of 785.5 runs. So I talked about center. Now last S is spread. Remember, spread, you could use range or IQR, okay? We'll use range. Range is max minus min. So you should be doing 901 minus 646. So, and the spread is the range of 901 minus 646, 255 runs. Okay? So when you see describe distributions, shape, outlier, center, spread, you should be able to describe it in 2 sentences. Okay?